Hey guys, we are going to do the homework for 7-1, so let's take a look. You're going to upload your notes along with these problems, and don't forget to do your lesson checks as well. Okay, so our homework assignment is 16, 17, 19, 22, and then a couple more on the other pages. So let's take a look. Method 1 states, step 1, we connect the lines, right? So my center of dilation P, I'm going to draw my rays through the 4 vertexes, right? And it says trace A, B, C, D and point P. Draw the dilation of ABC using point P as the center. Actually, I've done that. Sides that are 2 times as long. Okay, so when I look at segment AP, I want to go another segment about as long. When I look at segment PD, I want to go another segment as long. All right, is that making sense? When I look at segment PB, I want to go twice that long. And last, when I look at segment PC, I want to go twice that long, double that, and I get C prime. Now, kind of looking at the second method, when I connect these lines, the last step, connect these lines, but also try to make sure that they're parallel. So this line should be parallel to that line, and if it's not, maybe clean it up a little bit so your drawing looks more precise. And there you go. Okay. So my original shape, ABCD, is now been dilated by a scale factor of 2, meaning we enlarged it. Right? Question number 17. How are the side lengths of the pre-image and the dilated image related? Okay, so how are they related? So if I connect, the same thing, I got to connect P and P prime, connect Q and Q prime, connect R and R prime, connect S and S prime. So it looks like here is my point of dilation where they intersect. And this is like our example 2 in class. How are these sides related? Okay, so we can see here that they were it looks like from my point of dilation, I'm going to call this O for my origin. OP looks like it's about 6, right? And OP prime looks like it's about 3. So it looks like the scale factor here is 1/2. We'll also notice that affects our side length. So our pre-image was 2. Now our pre-image or our image is 1. So that makes sense, the scale factor. So my height, my old height, multiplied by my scale factor would equal my new height. All right, so my old height of 2 times my scale factor 1/2, my new height is 1. Now let's take a look at my width. So my old width of 4, times my scale factor is equal to my new width. And that's exactly what we have here. My old width of 4 times my scale factor is equal to 2, my new width. So that's how those side lengths of the pre-image and the dilated image are related. There's a scale factor of 1/2. the new dimension is half of the old dimension. Cool. Now we take a look at 19. What are the coordinates of this? So that's a dilation factor, scale factor of 1.5, which is the same thing as 3 over 2. 1 and 1/2. What are the coordinates of, all right, so it looks like I'm going to have to graph this. What are the coordinates of that if our original coordinate are this? All right, so I'm going to try to, since we're skipping 18, I'm going to just try to use this as graph paper. It's not going to work out perfectly, but we'll go to try. So I'm going to make this my origin. And 2, 8, 4, and -5. Okay, so the first coordinate A is at 2, 0. So that would be A. And the next coordinate is 8, -4. So 2, 4, 6, 2, 4, 6, 8, -4. That would be B. C is 4, -6. So 4 and drop it down 6. And this one's going to be off the page. So D is -5. -5, -10. So that's -7, 8, 9, 10. Okay, so somewhere over here is D. Did I do that right? Let me check these coordinates. 2, 0. Yep. 1, 2, 3, 4. So that's 8, -4. Yep. 4, -6. Yep. And -5, -10. So 2, 4, 6, 8, 10. That's right. That makes for a weird shape. All right. So if we go back to example 4, how did we do this one? Okay, so we dilated it from the origin and we just sketched it. Okay, so from the origin, this is 2, right? From the origin to 2, OA is 2. And OA prime we have to find out because it needs to end up being a scale factor of 3/2, right? So that means OA must be 3. So I went a distance of 2, right? And I need to go a distance of 3. So that's where I have A prime. All right, now we'll try to do it from B. So I went on a distance AB. I got to cut that in half and go a distance of 3. So I went on a distance OB, there it is. And I need to go 3 of those. So 1, 2, and another 3. Be right about there, B prime. Do it one more time. I went on a distance actually 2 more times to C, OC, if I cut that in half, so 1, 2. So here, this would be C prime. And then one more time. I went on a distance OD, cut that in half. And I got in one more distance. All right, so this would be my new coordinate for D prime. This is a weird looking shape. Okay. So what are my new coordinates? So it looks like my new coordinate for A is 3, 0. My new coordinate for B is, let's see, I went down 2 over 4, down 2 over 4, down 2 over 4. So that's a total of down 2, 4, 6. And over 4, over another 4, over another 4, that'd be over 12. C. It looks like I went down 3 over 2, down 3 over 2, one more down 3 over 2, so that's a total of down 9 over 6. And D, I went to D, I went back 5, down 10, so that's the same as back 2.5, down 5, back 2.5, down 5, back 2.5, down 5. So back 3, 2.5, so that's 5, 6, 7.5, back 7.5, down 15. So you might be thinking, was there a mathematical way to do this? And I believe that the answer is yes. We could have just multiplied each coordinate by 1.5. So let's see. What I mean by that is 2 times 1.5 is 3. 0 times 1.5 is still 0. 8 times 1.5 is... that didn't work. That's the way I checked my mistake. I wrote down the wrong number. So it looks like B prime, I did write down wrong. B prime, I went down 2 over 4, down 2 over 4, down 2 over 4. So that means I should have written positive 12. Yeah, let's fix that. Positive 12 down a total of 6. Yeah. So 8 times 1.5. Negative 4 times 1.5 is negative 6. Yep. Oh, so I flipped these. Maybe you noticed that. I flipped this. So this should be 6, negative 9, because 4 times 1.5 and negative 6 times 1.5. And it looks like I did that one right. Okay. So I could have done this. This is interesting, guys. I could have maybe done this without graphing at all. I just needed to multiply every coordinate by 1.5. Interesting. Okay. 22, what are the coordinates of the center of dilation? Okay, so that's, all I do is connect those lines and make a ray like we did in class. Connect E and E prime. Connect F and F prime. So that's back 5 down 1, back 5 down 1. So I end up landing there. Same on this other side. To get from G to G, G prime to G, I went back 5, 6, so back 5 to 6. So I'm locking in on this coordinate right there. That seems to be my center of dilation here. I go through that line. Yep. So what is my center of dilation? All of those lines seem to be meeting at the coordinates. If this is the origin, right, -1, positive 3. That is my center of dilation. Nice. All right. Question 24. Model with mathematics. Alex draws a scale modeling as a plan for a large mosaic. The wall is 10 meters by 7 meters high. What is the dimension of the largest mosaic he can make on the wall? Okay. So these are the old dimensions, right? These are the old dimensions, right? And this is my model of my new dimension. And we know that my new dimension, or my new length, so I'm going to call this AB. I knew that my old length, AB, over my new length, A prime, B prime, should equal my scale factor, right? So they're wanting to know what's the largest I can fit. So if my new length is 10 meters wide, so AB is 10 meters. Then my old dimension of width is 12, and my new is 10. Now let's look at my height, so I'll call that C, C prime. So that's 10, and this is, oh, my new one is 7. Now it looks like it's getting smaller, right? But remember my dimensions are in centimeters. So this is, my new one is meters, right? And I can add 2 zeros, that's meters. Or I could say that's 700 centimeters over 12 centimeters. Does that make sense? Actually, those are 10. AB is 10, so I could call that 10,000 centimeters. And that's 12 centimeters. As far as height, that's 700 centimeters over 10 centimeters. So that's a scale factor of 70. Let's see, if I took 12 times 70, what do I get? 840. Yeah, so that's the biggest one, is a scale factor of 70. The largest mosaic he can make is 7 times bigger. So 840. This would be 840 centimeters. Over 12 would be 70. So it won't take up the whole wall. So what is the largest? So the largest would be 7 meters high by 8.4 meters wide. All right. All right, last one. Alberto wants to make a scale model of the Wright brothers glider. Okay. Looks like we got 3 parts to this here. So we've got our wingspan, we have our length, and we have our wing area, and we have our height. Okay. So it says the wingspan of the scale model must be between 15 and 18 centimeters. What scale factor should he use? So again, my old dimension times my scale factor equals my new dimension. So I could also say my scale factor is my new dimension over my old dimension. Notice I just divided by old dimension on both sides. So what scale factor can be used? My wingspan, 9.8 meters. And what is my old dimension? And that says 15 centimeters. Now I could turn that into centimeters. So that's a scale factor of 653.3 repeating. Now it said I could use anywhere between 15 to 18. So if I did the same thing, right? But I put 18 centimeters. Let's see what that does. 9800 divided by 18. And I get 544 repeating. So what scale factor should we use? We should use anywhere between 544-ish to 563-ish. Now notice you're like, well, wait, what we use for the model, we should have actually divided because our scale factor is really big and our scale factor should be a number less than 1. So we should have, let's rethink this here. Our new thing is actually, it looks like we start with the big object and end with the little one. So our scale factor should be a number smaller than that. All right, so let's rethink this. Our scale factor, our new dimension is actually the smaller 15 centimeters, and our old dimension for wingspan is 9.8. Right? So and that's in meters. So we can put centimeters over centimeters. 15 divided by 9,800. Very small. But again, that makes sense. Our model's really small. And we could also do it with 18. Putting them in both in centimeters. And we're going to do it with the number 18 now. So scale factor between these two numbers. Okay. What will be the length, wingspan, and height of the model? Okay. So I'm going to pick a round number between these two. I'm just going to pick my scale factor as 0.0016. That's my scale factor. What will be the length of the length, the wingspan, and the height of the model? Okay. So here's this formula. My new dimension of my model should equal to my old dimension times my scale factor. So my new dimension of my length should be my old dimension, 2.4 meters, times my scale factor. And I want that in centimeters, so I'm going to list this at add 2 zeros, 240. Wait a minute, just let me get this straight here. I just made a little snafu mistake again. Ugh, so frustrating. If I multiply that by 100, I only get 980. That's what I just realized my problem. Yeah, 9.8. Okay, so that's centimeters. So let me just refactor that. Everything's going to be right. I'm just off by a decimal. Okay, there you go. I need one less zero. Okay, so fix this up a little bit, yeah. So let's make this 0.6, so my scale factor. $240 times 0.016, 384. And that's in centimeters. Oh, that's my height. That's interesting. So I'm like, oh, that's kind of short, but again, 2.4 was my height, so that's my new height. And let's do length. So my length before was 4.9, so I'm going to turn that into meters. And I have my wingspan. Is 9.8, so that's 980 times 6. Which, notice, does fit between there. All right, part C, what will be the wing area of the model glider? All right, so that's a meters squared kind of a thing. So if both wing sections are the same side, what would be the measure of each wing section? So my new wing area (28.3 meters squared). But now I have to have 100 meters to 1 centimeter, and I do that again, 100 meters to 1 centimeter. I have to convert it to centimeters squared, right? And I have a scale factor of that squared. All right, so let's see what we get here. 28.3 divided by 100, divided by another 100, and I'm going to multiply by 0.016 and multiply by another 0.016. I get a teeny, teeny, tiny number. Oh, what am I thinking? No. Mess that up. 1 meter is equal to 100 centimeters. Yep, that makes more sense. 1 meter is equal to 100 centimeters. Now we're talking. And then I'm going to multiply by that twice. Okay. 28.3 times 100 times another 100 times 0.016 times 0.016. Okay. Oh, now we're talking. So that would be 7.24 centimeters squared. And those are centimeters on my model. If both wing sections are the same size, what will be the wind dimension of each section? So I'm just going to divide that by 2. And I get each 36.2 centimeters squared. Nice. Thanks for joining me. Check it out the next video. See you next time.